pictures ever show up? It's a pretty crappy job, isn't it? Every one of them windows leak.
This is what we look for when we come up to an opening before we start anything. Is to make sure all this is flashed in the way it's been done. You know, like we've got a job right now, they've been calling us on for about 4 weeks telling us mock-up's ready. They haven't done nothing like this. It's just an opening like this right here. We keep telling them we can't do it. That'd be on your Crisco job. Okay? So once this is all in and stuff like that, then we can go ahead and put the window in. This is our sub seal, just like what we showed y'all previous. There's your stair masonites underneath it, giving us that quarter of it in. And then we just bank it down. We go over and bank that down there. Start the outside in place, so it's probably and we put that in dry. We don't put any caulking underneath it or anything like that. We'll come back and after he gets that in, then we'll go through and we'll do our sealants in the flashing before we set the frame. Show y'all what that's supposed to look like. Y'all can feel free to walk up here and look at anything. And get all this ready to set the frame in, then we'll set the frame in, and then we'll actually caulk around the frame right here also. And then we'll go ahead and get an anchor head. This window right here, we're going to show you a different application. We're going to actually do a head can clip. This right here gives the frame the movement. So it'll just set in here. In this application, it's going to be pretty tight, but it can be as far as that far off of it and still work. It's just there's got a line on it right there where we actually, the line right about in the middle of it. That's about where we want the frame set at. Okay, and then that way it gives its ability to have that much movement. But we went on ahead and we put straps on this one just to show how we can strap it back to the metal stud and not have to penetrate through a lintel or something like that.
Y'all found that?
You can get one that's got a depth of about 2 inches back here that we can that's pretty standard. The reason we do a lot of this right here is because so many different applications. Sometimes the sheetrock butts up to the frame, sometimes the sheetrock tucks into it. So we'll also go ahead and make a Z right here for the applications where they want the sheetrock to tuck into it. There's a couple of different methods that we can use. And typically we do it this way because it's more versatile for us. We can do it quickly and we're not ordered. We try to do everything in-house as much as we can. We try not to buy out anything. We've even got our own custom storefront system that we use ourselves. That we haven't been using it as much lately just because, really honestly, storefront jobs are kind of getting pushed to the side because we're sticking the windows out so far that actually we're using more of this type of a system, which is a front set system, and we can get this in a 6-inch system. So for the larger wall cabinets, we're having to use a lot more of the 6-inch system versus the 4.5-inch system to cover it. But he's got this one just about all caulked out stuff. He's gonna go in there and do it, and y'all can look at it and see what a flashing should look like before the window's put into it. You see that we actually go around our flashing before we set the window in against the structure. That's very, very super important because now we've made this window independent. That way, if there's a leak over here, it can't come past that right there, and it won't show up in here. We tried our hardest to divert the water back to the outside. So we do talk around those indents just like that. And then once he gets the window set, then we'll show you another way that we do it. That right there is pretty much the typical way we put things in. And a lot of, don't mean this to be smart or anything, but a lot of people don't do that because that's not really the window. That's not, but we just know that from experience, it's better for us just to do it. Cause if there's a window, if there's a leak anywhere within 10 foot of a window, we're getting a call. So we'll try to eliminate anything we can.
Well, that was the other deal I heard. I just had the guy tell me the other day, oh, well, it won't leak, so that we can stop here. And no, we're here to tie these two together.
Right.
Almost made it too small, didn't it?
Might be pretty tight.
I'd rather be too tight than small.
Now, the other thing that's really important is, you know, since we are installing windows before the veneer is put on or anything, it's very, very important that the veneer stays back a minimum of 1/4 of an inch. You know, everybody thinks they're doing us a favor by running that brick right into our frame and touching it. It's not. It's actually, we will throw a fit if they do that. We'll make them come back and take it off and get us that minimum of 1/4 of an inch. We like to work with a 1/4 to 3/8 of an inch. That way we can get a proper bead in there. And where if the brick is up here tight, then all we can do is just lay a bead on it. And it's just purely cosmetic. It's not a functioning bead at that point.
I think we call
Meetings, we preach and harp on it. When they first start running the bricks, we're out there complaining to them that you can't do this. Trying to make sure that they don't do that. But again, like I say, they think they're doing us a favor. Now this is a strap back anchor, so this is something that you can be used with, you know, a lintel, kind of loose lintel, hard lintel, whatever it may be. That way you strap back and anchor back to the actual structure itself. And this is a, you know, like I say, a 2 by 4.5 inch center glaze window.
Oh, sorry, Greg, you weren't out. We're pretty well finished. I believe it was okay, but they so guessing.
All the way around. Then we will actually, we got one more step in that. Is something that, Ray's really been pushing us to do along with y'all, is we are putting a second bead of caulking, which will be the second bead after the perimeter bead with the veneer has been put in place. So we always will run a bead down it right there, then the membrane will come back and cover that bead. So we'll go ahead and get that bead in place. We went on ahead, we've got one water deflector in place that you can see, and we've got one water deflector over here, it's just plastic. So y'all can actually see, if you want to, put it in there and see how it looks, how it actually works, how it goes in, how we leave the front of it open for the water to route out to the outside, run down to the seals and come out the weep holes in the bottom of the seal. We don't make that bead right there very pretty because it's never going to be seen. It's more for function than it is for looks. It's going to be covered up. So that's the that's how the window would look right here before the waterproofer does his thing.
Yeah, that's the reason we've gone to 6 inch.
But again, architects. We're asked to not necessarily do this deep caulking. We're asked to do it on the inside. And to us, it really doesn't matter. I know, Ray, you may have a preference where you like to see the caulking at. We usually do 2 beads of caulking. One's, there's no choice, it goes on the perimeter. The second one is a choice.
Yeah, so we've also had issues with specialty brick where the face of brick is like 7, 8 inches out. That puts my whole frame out of the opening.
Right.
The entire frame is not sitting inside this opening.
Right.
If it's like, you know, they put block on there or something, and if the block's out here, my whole frame's out.
And that, the 2x10 is still not beneficial.
No, then they have to go in and like a
Horrible.
steel angle or something.
Yeah, steel angles generally is what we deal with then. And so there's I mean, look, we're pretty versatile in what we can do. You know, we can pretty much adapt the window about whatever they leave us. But 6-inch would make everybody's life a lot easier. But where they've got like a lintel, a fixed lintel, they will actually come back a lot of times and put a nailer in between the fixed lintel and the structure to give us something to anchor to at that point, and also to shim their lintel out to catch the brick, because they had the same problem. You know, a lot of times they'll specify lintel depth, but it's not be long enough to get what they wanted, so they'll move it out instead of changing the size of the angle. We always do a compatibility information sheet, you know, get all the information of what we're going to be touching. We run it to our sealant manufacturer, they check it, and then we give out the same information to anybody else, and then they check it also. So your thing seems to be the best thing that works everywhere. So
Rodney, are you running into any problems right now on getting materials made of the urethane?
not at this point, but we are having a little bit of issues getting aluminum, and we are having a little bit of issues with our glass. Yeah, just because, and that's another problem that we're having. I know it really doesn't have anything to do with this, but the glass is changing so rapidly because of the energy codes and stuff that they're also becoming obsolete by every 2 years. So the glass is vanishing. That, like, well, the glass that we're putting into Denton High School right now is a brand new project. 2 years from now, we probably won't be able to get that same glass. Won't be probably not. If we can get something close, you know, the new product that they'll come out with, it'll just probably be a better energy efficiency than what we've got installed right now.
Well, will it be a thicker paint?
No, it won't be any thicker. It'll just be the different low-E coatings. You know, right now, you know, the law, whenever they finally switched everything over and said every house has to have low-E glass, it was a 0.4. Now, we can't determine that. The architect has to determine that, because he's got to put the input in of the insulation of the wall, the BTUs of the heat, the air conditioning, all of this stuff goes into that factor, what the roof is, to determine what that window needs to be. You know, they call it the 4.0 program, that they put the information in and it says pass or fail. And you just gotta keep playing with that number on the glass until it passes. And, you know, right now, a 0.4 is something we can't even get anymore. I mean, we're down into the teens now. So we've got, the glass is completely different than what it was even a year ago. So it's improving that fast. As one supplier comes out with something, the next supplier is coming out with one that maybe will be a 0.5% better. So they'll start working on one that's 0.5% better than that one, and before you know it, that one that was existing is gone. And we do have jobs that were less than 3 years old that we can't get the glass for anymore. It'll just be the different low-E coatings. You know, right now, you know, the law, whenever they finally switched everything over and said every house has to have low-E glass, it was a 0.4. Now, we can't determine that. The architect has to determine that, because he's got to put the input in of the insulation of the wall, the BTUs of the heat, the air.
Flashing for a second, we're using a product here that is a primerless butyl-based adhesive. So this is gonna be a little bit different than what we've seen for, you know, the last 20 or 30 years, where it was an asphaltic black material. So we're trying to get asphaltics out of the building envelope, and so we're seeing more and more synthetics. So this is an example. So it doesn't use a primer, and people think, oh, it doesn't use a primer, so maybe it doesn't stick as good. So I wanna pass this around and just feel it. Shit is so sticky. He's having he can occasionally have a hard time, because if you got one shot, and you place it on the sheathing and you're off, it's real hard to get off. So we saw some photos earlier about the interior detailing. The key is going to be our screw heads and our sheathing seams. So he's gonna go ahead and add the sealant and cast it out of 2-part epoxy. So yeah, we make these tools in-house, we give it a try, pretty easy. So these tools make it to where you don't have to have experience and it goes right the first time. Let me see that, Charles.
You are getting it too, you know? Right. So what, you had, you like all in here? That's it.
Cake started. I mean, we're ready.
Al, would you put it on?
What were you saying about those screw holes?
Oh, well, they're not overdriven, we don't have to treat every single one, especially with this one. So there's a few here that are deep, there's a few that are missed.
Generally, they're deep on the job site. So they run them in there as hard as they can.
Well, yeah, it's a different thickness, so most of the manufacturers, they want this 2-inch thick, but a little bit. Trimco wants 1 inch wide, but a little bit more thick.
Which one sells the most product?
That one, it's almost the same.
See, they want the one selling the most product.
Usually you would be correct.
So did you get the, I'm sure we did.
go around and shake everybody's hand.
So we checked this one. We checked this one at 4 spots, and it's showing 60 mils all the way across. We've got about 12 mils more than we have to have.
Is that right?
So it's 48 is what this one requires. So if we're doing the whole building at 60, I'd probably be pissed because that means we got a percentage of waste there. It's not necessary. So a lot of times guys are like, oh, I got at least the amount that's necessary. But that's not necessarily good. You want to get as close to the right amount. So what about compatibility? These are made by the same manufacturer, all the elements you see, so everything's good. But if you've got parts and pieces that maybe they don't like each other, either personally or chemically, then you could have issues. So if you've got two competing manufacturers, probably not going to be real willing to write a letter saying, oh yeah, you can overlap other people's stuff on us.
A curtain wall frame, which is a totally different installation of what we've shown prior. So this one is, probably have to come over here and look at it if y'all really want to see it. We've got an F-clip anchor at the bottom and an F-clip anchor at the bottom. And so we have to remove the seal in the head in order to anchor the window into place. But see how we anchor those differently than we do anything else. We do not flash these either. The flashing is typically, this will run all the way down to the slab, typically, and so the flashing is where we really don't need the flashing, and it kind of interferes more than it helps. So the flashing the way this cocks back, remember in the details, the pictures and stuff we were showing y'all earlier, it cocks in a different position than what your other two frames do. It cocks back behind the glass line. Now, this one is the system that we choose to use, which are probably never going to see it ever on another job other than the job that we do. This is called U.S. Aluminum's 4500 curtain wall. We use it specifically because of the desire Cisco has. And it gets the caulking beat out farther than a typical pressure bar system. A typical pressure bar system would caulk back here, right back here. This would be your main perimeter caulk bead back here behind the glass line. Where this one has got the provisions to come bring it out further so we can move the caulking further out. Actually, you can see this is the seal, and this is where our perimeter bead of caulking would be, right here. This is the glass line, and the caulking would go right there. Okay, and on a flip it around, now this is kind of showing you what a pressure bar system would see, which is more likely what you are going to see. This is where your caulk bead, your perimeter caulk bead would have to go, back behind your glass line, right there where I'm pointing at. The glass line would be out here. Okay. A lot of architect stuff, they don't like that because it leaves a voided area, and we will not seal in the bottom. It's got to be maintained open. That's where all the water runs to the verticals, and that's where that's where it's routed to come out the verticals and come out at the bottom. Okay, but this one is a little different design, so it can be caulked out of here, which architects seem to like a lot better. And it doesn't have as much gap. It still's got a face cap that goes onto it, which is about 1/2 inch thick. So there's just a little bit of depth perceptions of how far that caulk bead is on that one. So aesthetically, they like it better. We have in some cases caulked the heads and the jambs, but we refuse to caulk the seal. It's got to be left open. But anyway, that's kind of the difference in the curtain wall versus what we got in over here. And it flashes a little bit different. Also, sometimes we actually will glaze their membrane into our pocket. We will take if this was a actual true jam, this would be this would not be there, okay? It'd be just like this on both sides. So what we've done in the past is we take the membrane and roll it into this pocket right here. And then put the glass in it, and then put the face cap on it. Every manufacturer, they cover their butts. They have things in there to where they can always find some reason to say installation error. So you have to pay attention to the things that are most vital and important. This is really, really important. This is the most utmost important right here. This flashing right here with the end in, done properly. You can mess up here a little bit, this will cover you. If this is done right, you can make a mistake or two up here.
Hey guys, can we talk about air barriers for a second? So you'll notice we've got a different color that's going on this wall.
Yeah.
So the question is it just another color of poopy? Is it just another brand? Is there a chemical difference? Is there a physical difference? The answer would be yes, there are some very specific differences here we want to look at. So the red one is what we call a 10 mil system, so this is 10 to 12 mils. So it's not very thick, and it's been tested to a certain performance standard. Now if you look at the other coating we did, 48 mil thick, also tested to some certain performance standards, but it has a higher performance standard. There's a cost associated with it, so it might be 40, 50, 60 cents a square foot difference. So there is a number that makes a difference on a project that has a very tight budget. Now, for most of the things that a 20 to 30 year building life needs, is a thin mill system going to be sufficient? Yes, almost certainly. But if we're talking about a 100-year building life, or we're talking about a super high performance scenario where they don't mind spending the extra money, generally speaking, a higher performance system is the way to go. Now, thicker is not necessarily higher performance. This is really, really important. So it has to do with what it was tested to, what standards they use. So there's some 25 mil systems that are really robust and will outlast the whole building. They're very, very expensive. You don't have to have 48 mils,
not my
60
alcohol,
mils,
is it?
or 90 mils like some other systems.
No, I got it right
You
here.
don't necessarily need more
I hope it's not.
material
No, it's
to
not.
get a higher performance system. So then it comes down to what's the. Does anybody have any questions?
We're pretty well done. This last application over here is a curtain wall frame. If y'all want to come up and see it, the water deflecting and the joint plugs and stuff are done differently on this than they are versus a center glaze or a flush front type system. And we purposely left them out on one side of them just so you could, so everybody could see. So, and it's a totally different anchoring system also. It's used with F clips top and bottom, and your middle verticals are done with T clips and anchored on both sides of your verticals. And then the curtain wall floats on those clips, and so it's got a lot of movement built into it. But that's pretty much what we've got for the curtain wall. We've got like the what you should be looking for. And we have a rule in our company. Not everybody has this rule, but we do. There's 4 people in our company that one of the 4 people have to look at every curtain wall before one piece of glass can be put into it. And what we're looking for is this. We're making sure this is done correctly. All of your joint plugs are done right, because in a curtain wall, the way the water can migrate, you can have, if you had a curtain wall, we'll caulk over the screw heads, we caulk that joint real well where no water can suck back into it or anything like that. But the problem with the curtain wall, even though it's supposed to ride out through down your verticals like this out to the front and run out at the bottom, sometimes you got a 20-foot long curtain wall, your problem may come up over here 3 panels over, but the water's showing up over here. So once you have a leak in a curtain wall, it's very difficult to find. So we have that. It's always been a set still deal for us for curtain wall. It has to be inspected by either myself, our vice president of operations, or one of my 2 field superintendents before glass can go into it. Once glass goes into it, we can't do a lot about it, other than pull the glass back out and start over. So that's something we harp on very strongly. So that's something that y'all would be looking for if you're looking at window installation and writing your reports and stuff. Do they have the joint plugs in? Do they have the caulking smeared all over the joint, covering the screw heads and stuff like that? Anybody got any questions about any of that? And like I say, the membranes come into it a different way than they do a typical window application. But we sometimes will glaze it into the pocket. Sometimes it'll go to just up to the and attach it, just like this one was done. And then sometimes if we've got an open back system, we'll put a piece of angle in it to where the membrane can go and attach to that. So there's about 3 different methods you really can use on a curtain wall for the membrane. And then also, I know it's a big deal for Frisco and Allen, Denton, is pretty big on it too, about cutting the, slot in the concrete slab behind the curtain wall and putting that water stop in there. That one right there. So that's also something to look for. A lot of the contractors, when we bring it up to them, they say, what are you talking about? We're like, well, if you look over here on the cloaking details, you'll find that detail. And they're like, well, we don't have that. So they don't wanna do it. And Frisco's a little bit more lenient. If it's got an overhang on it, they'll let you get by without doing it. But if it's got an overhang, if it doesn't have an overhang on it, you will definitely have to do it. And it has to be cut before the frame goes into place. It can't be an afterthought. So we go out and we'll mark it for them, all that. We don't do saw cut. We do provide the metal because we want it to match our aluminum, whatever that is, whatever color it is, we'll put a matching color in. And we got away from the stainless steel because it kind of proved to be a hazardous issue for small children.